Okay, so after this merger simulation exercise that was done by the European Commission in this universality case, let's now go to a paper which again does a merger simulation, a paper by Bjørnestad and Verboven, published fairly recently, which indeed also does a merger simulation, but the difference here is the following. So in the Commission case that we just looked at, basically what the Commission had been doing was a prospective analysis. So they asked, well, we have the current situation before the merger, and we're going to predict what's going to happen to prices exposed based on this merger simulation. And in response to the outcomes indeed of that merger simulation, they decided to do something basically about the situation, and asked for some commitments on the part of these merging firms. So what Bjørnestad and Verboven were able to do in this paper was sort of a bit more unusual, I guess, which is doing a retrospective analysis. So basically what happened, or what's the case that the Bjørnestad and Verboven analysis deals with, is a merger simulation in the Swedish market for pharmaceuticals. And actually, at the time of the merger, Bjørnestad and Verboven were actually involved in a merger simulation to assess the effects of this merger, just like the Unilever Sara Lee case. But in this particular case, actually, the competition authority decided to just allow this merger full scale, so not to block it, not to ask for any commitments, even though there were actually some potential from the merger simulation. You might argue there were some potential price effects that might have been worrying, and you can read in the paper actually why the competition authority did not actually take any action on that. And what Bjørnestad and Verboven afterwards did was, well, we have this merger which went ahead. We tried to predict what happened through merger simulation with prices. Well, let's see what happened in reality exposed. It's a retrospective analysis. We have a look at what prices did as a result of the merger and compare those with what we had anticipated on the basis of merger simulation ex ante. So we can compare the actual with the simulated price effects. So that's actually pretty nice. So that allows for a test, if you wish, of such merger simulation in an actual real world situation. So what was this merger? So it is a merger between, as I mentioned, two pharmaceutical companies. So AstraZeneca Tika, which is an affiliate of AstraZeneca, and GlaxoSmithKline, both in the Swedish market, and particularly the Swedish market for analgesics or painkillers. And as I mentioned, so this played in 2009. This story was set in 2009, and the Swedish Competition Authority cleared that merger. So what was this particular market? So here you see the companies on the left hand side in this table, which comes from the paper, obviously. So the first two companies here, AZT and GSK, those are the two merging entities, and all those other companies from McNeil up to Bayer, they are rivals, outsiders. So you see that AZT in particular has two different brands, and GSK, GlaxoSmithKline, only has one brand. And also the other companies might have more than one brand. On the horizontal line on top, you see different types of painkillers. So the first column here is the paracetamol type of painkillers. The second one is ibuprofen kind of painkillers, and the third one ASA, that's acetyl salicylic acid, which is basically aspirin. So you see that these different brands actually use different active substances in their painkillers, in their analgesic products. And in particular, we see that those two merging companies actually have a large market share in the paracetamol. Actually, they're in this table, they're the only producers of paracetamol painkillers in the total market of all painkillers, so paracetamols, of course, do compete with presumably with aspirins and also with ibuprofen. But the paracetamol market, they are actually together they dominate that market, and that's 42% of the total market for painkillers. So, and then ibuprofen is supplied by these other firms, and as well ASA is also provided by. So aspirin is also provided by these other firms, and you see that actually in this aspirin market, it's in particular this McNeil brand, which has a large market share. So these are the firms and the products that they compete on. This basically is the market, so the Swedish market with different types of painkillers. And well, this is basically what happened. So this is data, right? We are looking here at what happened to prices before and after the merger. So what is this? You see this on the horizontal axis. You see time, and actually this merger took place, and the vertical red line somehow in the middle here, basically over here. So that's point at which this merger took place, and well, something's happening. You can see that here. So what are these lines at which something is happening? Well, so the blue dashed line over here, that's the prices of paracetamol. So that's the prices of those products that are produced by those merging companies, so the GSK and the AZT companies. And you see indeed those prices rise by quite a big extent, by almost 40%. What can we also see? Well, the ibuprofen actually is not that does not respond that much to this merger, but on the other hand, the ASA, the aspirin market, or the products involving aspirin, they also increase in prices after the merger took place by some 13.3%. So there was a big price effect, you might say, as a result of at least after the merger. So the question is, did merger simulation predict these price increases, right? So this is what happened. So nothing was done to stop this merger. How does this compare with what we might have anticipated through this merger simulation? So what was this merger simulation? Well, basically same kind of simulation as we just looked at in the deodorants market. So there's slight differences actually. So there's Björnsten and Verboven, the authors, actually compared slightly different utility function specifications, so they get several different outcomes, which are similar but not the same. And they also looked at different specifications in terms. So one of these is the nested logit model that we looked at in Severely, and they also looked at the random utility model, which is slightly different. So they compared these different types of merger simulations. That doesn't need to worry us. That's not going to concern us so much in this for this lecture, essentially. So in this nested logit model, so the stuff that we looked at in the deodorant market, so which they also did in this painkiller market, they identified two different nests, so two subgroups, if you wish, two subcategories. So the first nest is in terms of the form of the product. So they essentially compare some products which are provided in terms of tablets, regular tablets if you wish, and the other type of product is supplied in terms of fizzy tablets. So it's something you dissolve in water essentially. So those are two nests, and within those nests there's also a subnest divided up into these three different substances. So we have some correlation between diversion ratios, if you wish, within these nests of either paracetamol or ibuprofen or aspirin. Okay, so that's basically the setup of this model, and these are the results of their simulation model. So what you see here is the price increases as a result of this simulated merger, and you see that in the paracetamol, as a result of this merger, was predicted in the simulation to increase in prices by 41%. So that's actually, if we look back to what we saw in practice, that's actually quite close to what we saw in practice. So in practice, indeed, it's more or less 40%, and that's, if you look here, it's well within the confidence intervals around this 41% that we measured. If we look on the other hand that's sort of comforting, right? That merger simulation is apparently, at least as far as this figure goes, it's congruent with what you see in practice. What's slightly different from what was predicted is that the aspirin market, based on the merger simulation, was anticipated to increase in prices, but not by that much, only by 1.5%. Well, that's fairly different. It's a lot different, I guess, actually, from what we saw in practice. So in practice, the aspirin market also rose in prices by 13%, and that's not consistent with the findings from the merger simulation. What's also not completely anticipated from the merger simulation was this bit. So the average price change for paracetamol is pretty good in terms of comparing simulation with reality. But simulation actually predicted that the bigger market, the AstraZeneca product, which had the larger market share, would rise with a smaller amount, only 30%, 30.5% price increase, whereas the smaller share, GSK had the smaller market share, its prices would rise in the simulation by this very large amount. In practice, well, we can't see this actually in the picture, we only have the average here. But in practice, it turned out actually that both companies, both AZT and GSK, turned out to increase their prices by approximately the same percentage. So that's a different outcome from the simulation results. So some good things, some less good results based on this comparison between merger and simulation and reality. So we did sort of predict, the model did predict the average quite well, but not so much for the AZ and not so much for these individual results per product. So the next step that Verboven and Björnsen and Verboven took was to see whether, well, tweaking this model essentially might allow them to find an explanation for these differences. So what did they do? They explored, well, perhaps actually the original merger simulation assumed that costs were constant, were kept constant. Perhaps there were also changes in costs, right, as a result of the merger, and that would also explain part of the price differences. So particularly one of the cost categories that came to their minds was that, well, at the same time of this merger, there was also a change in the regulation regarding the package sizes. They were made smaller, actually, and for those products, and that might have increased costs for packaging in particular by some amount. So they tried to estimate in this paper what this potential cost effect might be, and whether that might actually explain another part of the price changes that we observe in practice. It turned out, of course, there's a little bit of that might be explained, but certainly not the whole difference between observed and predicted price changes. Another robustness test, if you wish, or another explanation that they tested was, well, if you remember, the original merger simulation had as an assumption, well, these companies are playing Nash equilibrium, are playing the Bertrand-Nash equilibrium, and that allowed us essentially before the merger to estimate what marginal costs are, and it also allowed us to estimate or to simulate what prices would be at the same marginal cost after the merger. But of course, Bertrand-Nash behavior is just an assumption. Perhaps the game that these companies were playing was not complete price competition. So the authors here actually asked the question, well, suppose that this market, well, not that many companies in there, perhaps this market was already partially collusive, there was some coordination in prices among these different companies. So that would cause the first order conditions actually to be slightly different, of course. So what they do is actually they test whether if we change the first order condition to also include part of the effects of your price changes on profits of other firms. So if you what does collusion do? It allows you to negotiate with these other firms, so to internalize, to some extent at least, also profit effects of your rivals, because somehow collusion allows you to care a bit more about what your rivals are earning, and it allows you to actually drive the price a bit more. So that's basically what the authors do. So they tweak a little bit the first order condition by adding indeed this internalization also of other companies' profits in response to price changes that you might make to your products. And they did this both before and after the merger. And again, they check, does this change the simulated effect? And obviously, again, this change. You can guess this will change indeed effects. Whether it actually is sufficient to explain the entire difference between observed and simulated prices, well, the authors conclude, well, not so. There remain some discrepancies. So something is happening here. We don't know exactly what. There might be other cost changes, of course, that they didn't look into. What might also be true is that as a result of the merger, there is actually a change in collusive behavior, right? So perhaps before the merger it was difficult to collude, whereas after the merger it became a little bit easier to collude among these companies. Well, if you include that, of course, you will again get at least a better explanation, in particular, of this aspirin price markup, change in markups as well. So that's basically what the Bjørnstad and Verboven paper does. So confront simulation with reality. So it's nice to have a look actually at that paper to see how they do this. So that's merger simulation with estimation of demand in particular. We can actually sometimes do something different, or let me phrase it differently. Sometimes it might be hard to actually estimate demand, because in order to estimate demand you need lots of observations. Obviously you need a lot of data, and sometimes we just do not have those data. So what can you do? Well, you could completely do away with merger simulation, but there might be another road to take here, which is to calibrate demand. So we'll have a look at calibrated demand in the next video.